All right, y'all. So what I'm gonna do, y'all, is explain what the vertex is and everything, and then we'll look at the math lab problems and find the vertex and actually graph it and all that fun stuff. So this will be 7.5, and we'll be doing what we call analyzing graphs of quadratic functions. And y'all remember quadratic functions, those are our x squareds. Okay. And we know that the x squared graphs make a nice round parabola. So I'm going to draw the basic graph here. So remember the basic parabola makes that U-shaped graph, right? So what we're worried about is what we call the vertex, which is that low point, or if it's flipped over, it could be the high point of the graph. So we're going to focus on the vertex of the parabola. All right, so technically it is the minimum or maximum point of a parabola. Now, a few things that we get from our and remember the vertex will be like an ordered pair of x and a y. Now, a few things we can get from these vertexes, though. It gives us what we call an axis of symmetry, which is the vertical line that cuts the parabola in half. So it gives us the axis of symmetry. All right, y'all let one more in here. So the axis of symmetry is an imaginary vertical line that sort of cuts that parabola in half. Now, the axis of symmetry comes in the form of an equation. Now, remember, since it's an imaginary vertical line that's cutting our parabola in half, it's going to be an x value, okay? Because remember when we was graphing the vertical lines, those were always in the form of x equals some number a. Okay, and a is actually going to equal the x value of the vertex. So a equals the x value of the vertex. All right, so we just said that the axis of symmetry is sort of like an imaginary vertical line cutting this parabola in half. Well, we also got what we call minimum values, or if it was flipped over, it would be a maximum value. So the minimum or maximum value, and we're talking about of our graph, because sometimes we want to know, well, what's the lowest amount you had or what's the highest amount you had. So this minimum or maximum value is equal to the y value of the vertex. And that makes sense, y'all. So these y values would be the minimum y values. Like I said, if it was flipped over, it would be the maximum y values you had. Now, we need to figure out, do we have a maximum or do we have a minimum value? So what we look at, if the ax squared term of the function is, so y'all, I'm looking at the first term of the function, the ax squared term. If that a is positive, we will have a minimum. If that a is negative, well, remember, if this ax squared term is negative, that flips the graph over to x-axis. So that means that we would have a peak or a maximum. Okay, so that's what these vertex tell me. The vertex gives me the vertical line that cuts it in half. The y value of the vertex gives me the minimum or maximum point of that function, okay? So y'all want to go into math lab now and just sort of get y'all familiar with this vertex, with this first problem they got in here, okay? So let me pull up math lab. I'm gonna make my graph a little bigger here. All right, so this part, use the graph of the quadratic function, f of x equals a, x minus h squared plus k. Don't worry about that. That's just an old formula they're using for this. To find the vertex, axis of symmetry, and the minimum or maximum value. Well, y'all, they're giving us the graph. So they want us to look at this graph and give them the vertex. Well, they got the vertex listed right there as an ordered pair. They're telling us that that vertex there is 2, 3. So you're going to come in here and plot that point 2, 3. Now remember, it's got to be in parentheses because this is actually an ordered pair. So once we put that point in, it's going to ask us, well, what's the axis of symmetry? Now remember, we know for sure that the axis of symmetry has to be like an equation. So you got to put x equals, x equals. And then what did we say the axis of symmetry was equal to? We said it was equal to the x value of our vertex. We already got the vertex, which is 2, 3. So the x value is 2. So that imaginary vertical line will split the parabola in half at the x value of 2. Okay? So remember, that's got to look like an equation. So you hit answer on that. And then, now it don't care whether we got a minimum or maximum, but y'all, since our parabola has a valley on it, it would actually be a minimum. But y'all, all they want is the minimum or maximum value of that function. Well, we said that was equal to the y value of the vertex. And y'all, let's see, my y value was 3. So I would put 3 in there and check that answer, okay? All righty, so to do this next problem, I'm going to have to give y'all what we call the vertex formula. Now, this is how we will find the vertex if we're not given a graph, okay? So let me go back to the pad here. All righty, y'all, so we'll flip that over. And this is how we will find the vertex when we're given a function and not a graph. So finding the vertex of a function in the form of f of x equals ax squared plus bx plus c. Okay, so there's my quadratic, got the x squared term in here. So y'all, to find the vertex formula and y'all remember the vertex is an ordered pair. So to find the x value, we find negative b over 2a. Sort of similar to the quadratic function the other day. Now, I got the x value. So when y'all was graphing by hand and you had an x value, to get the y value, you plugged that x value back into the function. And y'all will do the same thing. So to find my y value of the vertex, I'm going to find the function value of that negative b over 2a. So whatever this gives me, I'll put it into the function I'm given for the x's, and I'll evaluate that to get my y value, okay? All righty, so that's our formula we're going to use. So let's go to Math Lab and let's copy down this first problem so I can show y'all how to go through these. So look here, they want us to consider this quadratic function, f of x equals x squared minus 12x plus 32. So notice they want the vertex, axis of symmetry, figure out if there's a max or min, and then find that value, okay? So y'all, let's go back and work this. Because remember, the main thing I need is my vertex point. So this is just like the quadratic formula. You got to come in and find your A, B, and C. So there's no number in front of x squared, so that makes A a 1. B is a negative 12. C would be the 32. All righty, now we will say this. This is my x squared term right here. And remember, if I look at the x squared term and that A is positive, that means on my graph, we will have a minimum value. Now, if that would have been a negative 1 or a negative number, that would have flipped it over and we would have had a maximum, okay? So I do know because of the A that it's a minimum. So now I'm going to get my vertex. Okay, so my vertex, I'll have my X and Y coordinate. So I'm going to get the X value first. To get the X value, I got to find negative b over 2a. All right, so we got that negative we bring over. I'll now put in for b, which is the negative 12. So I'm going to put that in parentheses. So if your b is negative, because of that negative, you're going to have two negatives here, okay? Now on the bottom, I got 2 times a, which will be 2 times my 1. All right, also negative times negative makes that a positive 12 on top. 2 times 1 is 2 on the bottom. And if we divide that, 12 divided by 2 gives us 6. So over here is my vertex. At the moment, I know the y value, the x value is a 6. So then we find the y value. Now remember, for the y value, I said you find f of that 6. Since negative b over 2a gave me 6, I'm finding f of 6. So we're going to take our function and put a 6 in for both of these x's. So I'll have 6 squared minus 12 times 6 plus 32. All right, so I'll work this one out by hand, sort of show y'all order of operations. So 6 squared, 6 times 6 is 36. Then I got a negative 12 times 6 would be what, a minus 72. And then plus my 32. All right, so going through 36 minus 72 gives you a negative 36. Negative 36 plus 32 gives me a negative 4. So we now know that our y value is negative 4. So then remember, it asked for the axis of symmetry. Well, we got the vertex now, so we know the axis of symmetry will be x equals the x value of 6. So over here on the x-axis, at positive 6 on the x's, we know there's an imaginary vertical line cutting our parabola in half. Now to ask for, is it a min or max? And then the value of the min or max. Well, y'all, we said since our A right here, since that A was positive, we had a minimum. So we have a minimum. And remember, the minimum equals the y value of negative 4. So you don't have to put the negative 4 in as an equation, only that axis of symmetry, okay? Now, it's going to have us plot these. When we plot these parabolas, since we now know what a vertex is, the first point we plot has to be our vertex. So that would be what, a 6, negative 4. Now I'll show you the ways to get more points. You can put numbers right next to 6 into the actual function and work it and see what you get. Or you can go to y equals and graph that and use that table and find some points. But y'all, no matter what, whether you use that calculator or hand, this vertex has to be the first point we plot. So I think what I'll do, I'm going to do it by hand here real quick. So since my x phase is 6 here, I'm going to do one on the left side and a point on the right side. I'm just going to get points right around my vertex so that when I graph it, it's easier, okay? So first I would put a 5 into my function. So that would give me 5 squared minus 12 times 5 plus 32. All right, y'all, 5 squared is 25. 12 times 5 is 60, so that'll be 25 minus 60 plus 32. So let's see. If you add all these together, 25 minus 60 gives you negative 35. Negative 35 plus 32 gives me a negative 3. So when x is 5, y is negative 3. Now, y'all, what's neat about these, remember parabolas, since they're since they're symmetric, usually whatever point I get to the left of the vertex, I'm going to get that same value to the same point on the right side, and so on, okay? So you'll see that the tables are symmetric also. And y'all watch this. So 5 was one left of 6. 7 is one right of 6. So I'm going to do 7 squared minus 12 times 7 plus 32. All right, 7 squared is 49. Minus 12 times 7 is 84. And then plus my 32. So y'all, let's see. 49 minus 84 is a negative 35. Negative 35 plus 32 gives me a negative 3. Okay, so if these were in order, 5, 6, 7, you would see negative 3, 4, negative 3. Then the next points would match, and so on, okay? So each side of that parabola is going to sort of reflect the other side. All right, y'all, but we got 3 points, and remember, first point I'm going to graph is that vertex. So y'all, let's go to Math Lab. But what's nice is once you got the vertex, you're pretty much done. All right, remember, this vertex has to be an ordered pair. So we have parentheses, 6, comma, negative 4, close parentheses. So to make you put that in, find an equation for the axis of symmetry. We said that would be x equals 6, which was our x value. So this one, it opens upward and has a minimum, or it opens downward and had a maximum. We said ours opened upward and had a minimum value, and it was that negative 4. So you got to choose, do you got the min or max there, okay? Check that answer. And then we're going to graph it. So I'm going to click to enlarge the graph. We're going to pick the U-shaped vertical parabola tool. Now y'all notice, this just has 2 dots on it. So technically in MathLab, I don't need all 3 points. I just need my vertex and one other point. And if you look in the yellow, it says click the graph to plot the vertex. Okay. So we're going to go right to 6 and then down to negative 4. All right, so there's my 6, negative 4. All right, so this one's broken into, it looks like halves on here. Every time I move, it's going by halves. And y'all, I just needed one other point, so I'm going to do my 5, negative 3. So over here at 5, I'm going to go down to negative 3 and click it. So it's only making us plot our vertex and one other point, okay? So at that point, we would just click save, and then you're going to check those answers, okay? So let's see what we got coming up next. All right, y'all, so I'm just going to write this one down. So this one, we're going to use our calculator for a little help. So we're doing the same thing, vertex, symmetry, min or max, and graph. So I got f of x equals 2x squared plus 14x plus 24. All right, well, right off the bat, I know how this parabola is going to look because A is 2, B is 14, and C is 24. But this A is positive. So remember, since A is positive, this is going to be a minimum again, okay? So let's get this vertex point. So I'm going to get my x value first. So the x value was negative b over 2a. So bring down that negative. B is 14. So I'm just going to put my b in parentheses. And then on bottom is 2 times a, which is 2. All right, so on top I just had one negative. So that negative times 14 makes that a negative 14. On bottom, 2 times 2 gives me 4. Uh-oh, y'all. Looks like we're going to end up a little fractiony on this one. But I would reduce this fraction down by dividing both of those by 2. 2 is the biggest number they can both divide by. So negative 14 divided by 2 would give me a negative 7 on top. And then 4 divided by 2 gives me a 2 on the bottom. So on my vertex, the x value will be negative 7/2. Now, I'll probably work this by hand, but y'all got that calculator, right? So if you don't like doing fractions by hands, you got your calculator. But for us to find the y value, we're going to find f of a negative 7/2. So that means where I got the x's, I'm going to put in 7/2. And then I got plus 14 times 7/2. And then at the end is my 24. Now I'm going to work you at order of operations and just sort of break it down each step at a time. So if you wanted to do these by hand, so that means the first thing I'm going to do is the exponent. But y'all, when you got a fraction raised to an exponent, the exponent applies to the bottom and the top. We got to square both of those. So I'm going to bring down my first 2. So on top, I would have 7 squared, which is 49, over my bottom squared, which would be 2 times 2 is 4. Now, y'all, at the moment, that's all I'm doing is just squaring my top. Whoops, y'all wrote that in wrong. That's the 7/2 there. My bad. Somehow I accidentally put a 17 there, but remember that's our x's are whoo, they're negative 7/2, ain't they? Well, y'all let me just daydream on and go, okay? So remember, those are negative 7/2. So make that a negative. So we're good here. Negative 7 is positive 49. 2 squared is 4. All righty. Well, y'all must have been daydreaming on that, okay? So now I brought down my 14 times my negative 7/2 plus 24. All right, so all I'm going to do now is multiply this and this. Now, when you got a whole number times a fraction, you can put a 1 under the whole number so that you multiply straight across. So y'all look here. 2 times 49 is 98. 1 times 4 is 4. Now here we got a positive times a negative. That's going to make that a negative. 14 times 7 is 98. But y'all, this one's over 1 times 2, which is 2. And then y'all at the end is a plus 24. So guess what? By hand, we're at the point where we would try to add all of these. So since I'm dealing with fractions, I'm going to make the 24 look like a fraction by putting a 1 under here. Now y'all remember, to add fractions, I need what? A least common denominator. So y'all, the bottoms of my fraction are a 4, 2, and 1. What is our least common denominator? Oh, Jackson, get me a little bigger. So what y'all got now? 4, 4. Because remember, 4 is the smallest number that I can turn all these into, right? I don't have to change the 4, but I can turn a 2 into a 4, and I can turn a 1 into a 4. Okay? So the LCD would actually be the 4. So y'all, the first fraction's already got a 4, so bring it down. That'll be minus the next one. So what I do, whatever I got to do to the bottom to turn that into a 4, I'm going to do to the top. So here, you would multiply 2 times 2 to make that a 4. So we would also multiply the 98 times 2. And that'll give us what, a 196. And then here, to turn this 1 into a 4, I would multiply by 4. And I would have to multiply the top by 4. So 24 times 4 is 96. All right, so at this point, I know the bottom of my fraction will be a 4. So all we got to do is, y'all, figure out what we get from the top. So we got 98 minus 196 is a negative 98. Negative 98 plus 96. Oh, y'all, I'm getting a little different than y'all. Let me see. What are y'all getting up? Y'all, I'm getting a negative 2, which I'm going to reduce that to a negative 1/2. Okay. So remember, bring that denominator down first, and then do your 98 minus 196, which is negative 98, plus the 96 to get to negative 2. And then I reduce that down so that my vertex is a negative 7/2, comma, negative 1/2. So y'all, we would go back to the share and go to Math Lab, because I believe that's the first thing it asks for, our vertex. So in parentheses, negative 7/2, so that'd be negative 7 divided by 2, arrow right, comma, and then I got what, negative 1 divided by 2, arrow right, and put my parentheses. All right, at that point, we check our answer. All right, y'all, so this is on y'all. What I want to know is, what is my axis of symmetry? Oh, let me get you. So we know it's what? X equals, what do you got there? Negative 7/2, perfect. X equals Negative 7 divided by 2. Good job. We checked that. So we said this would have a minimum. So y'all, what you do on this, you click the A for minimum and hit enter. Then it wants the minimum or maximum value. So y'all, what is my minimum or maximum value? All right, so what y'all got? Negative 1/2. So negative 1 divided by 2. All right, y'all, we check that. Oh, so we need to graph it. So let me go back to my paper again. So we have to graph this, remember. So I know I got to plot negative 7/2 and negative 1/2. So let me show y'all how to graph this and actually get some other points on this, okay? So let me go to the calculator. And y'all, on the calculator, I'm going to go to y equals. And I'm just going to put that actual equation in, the 2x squared. What do we have? Plus 14x plus 24. So, and we'll graph it. And y'all remember when we graphed it, there's our vertex, which is negative 7/2. Negative 7/2 is basically negative 3.5. And then there's that negative 1/2 down. So I just want to look at my table. So I'm going to hit second graph. And notice, it's not graphing my fractions, but I know my vertex was in between that negative 3 and negative 4. So yeah, I can plot any one of them points. I could do negative 3, 0, negative 4, 0. I could do negative 5, 4, negative 2, 4. You see those graphs are sort of symmetric around those vertexes. Now, the reason it's not showing our vertex is because it's not plotting the points as fractions. It's going through the whole numbers, okay? So I'm just going to use negative 4, 0 as my other point. All right, y'all, so I'm going to click to enlarge the graph. Pick my parabola. Now notice this is set up as halves. You got negative half, negative 1, negative 1.5. If you was to turn negative 7/2 into a decimal, you'd get a negative 3.5. So I'm going to go left to negative 3.5. And then that negative 1/2 would be a negative 0.5. So I'm just going to bring that down once. So if you look in the yellow, I'm at a negative 3.5, negative 0.5. Click that. And then I said my other point would be negative 4, 0. So negative 4 to the left and 0, you stay there. And then you're going to save that and check that answer. Okay. All right, so let me do one of these that's sort of negative here. So y'all, let me write this one down real quick. F of x equals negative x squared minus 4x minus 7. So after this one, we'll skip through and maybe do some of the other problems here. So let's see what we got. A is a negative 1, B is a negative 4, and C is a negative 7. So y'all, my first question would be this. What will my parabola look like? Will I have a minimum value or will I have a maximum value? Oh, Mason, you done got me. You got a max on that. Good job. Whew, good job. So this parabola is going to be upside down this time because of that negative. All right, so let's get the vertex. Our x value, we said, is negative b over 2a. So that's a negative. And y'all, my b is negative, so that's going to give me a negative times negative 4 over 2 times our negative 1. Got a lot of negatives here, but the two negatives on top are going to make that a positive 4. The 2 times negative 1 makes that a negative 2 on the bottom. And y'all, 4 divided by negative 2 is a negative 2. So we know our vertex has the x value of negative 2. Now, here's where I get people on this problem. Because when these x's are negative, you got to be careful of these functions. So we're finding f of that negative 2. But y'all look here. Bring that negative down no matter what. For my x, I'm putting in the negative 2. I'm squaring that. Minus 4 times negative 2 minus 7. Now, you cannot multiply this negative times that negative yet. Multiplication does not have priority. The first thing we got to do is the exponent. So you bring this negative down automatically. Then we figure out what negative 2 squared is. Well, y'all, that's negative 2 times negative 2, which will make that a positive 4. Now here you're multiplying. So you're subtracting a 4 times negative 2, which will be subtracting a negative 8, which makes that a plus 8. And then at the end, minus 7. Because y'all really, this negative times that negative 2 squared, that's really this going on. Right. Negative 2 squared means you got 2 of those. So there's not only 2 negatives there. In all reality, that's 3 negatives. And that's why that stayed negative, okay? All right, y'all, let's see what we get. Negative 4 and 8 is 4. 4 minus 7. What's that? A negative 3 for us. All right, y'all. So we know the vertex. So let's go put that in. So once again, an ordered pair. What I get, negative 2, comma, negative 3, close parentheses. All right, so it's wanting my axis of symmetry. Oh, y'all are so close. Let's see. All right, Nat, you got it right there. You got to have an equation, y'all remember. So that's got to be x equals negative 2. Because math lab will sure get you if you don't put them x's. All right, y'all told me, well, go ahead, what, a maximum? So we're going to click B for the maximum. And what is the maximum minimum value? Y'all put negative 3. Yep, that's my y value. All right, y'all, then once again, we got to graph it. So let me go get one more point. So for my x and y table, I know I got to use -2, -3. So I'm going to pick another number that's easy to do. I'm going to do 0. So you can never go wrong picking 0. Because if you put a 0 into this, 0 squared is 0. So that's a big 0. 0 times 4 is 0. So that's a big 0. So when you put a 0 in for the x's, everything goes away other than the one number by itself. So 0 minus 0 minus 7 equals a -7. So I would probably, since I only need 2 points, even like the one on the fraction while ago, if I'd have used a 0, I could have got rid of that whole thing really quick, okay? So -2, -3, 0, -7. Let's go plot that. So click the enlarge graph, take my parabola. It's telling me to do my vertex, which was -2, -3. And then I picked 0, -7. And y'all look, that parabola is now upside down, like we said. So we would save that and check our answer. All right, y'all knowing what we just know. Is this true or false? The function f of x equals -9 times x squared plus 9x minus 2 has a minimum value. True or false? Hey, we're just saying false. Good job. Because remember, we just did one while ago with a -a, and we said a flips it over, and that makes it actually a maximum. So good job. That is definitely false. Now, knowing what we learned in 7.2, this x plus 2 squared. Does that x plus 2, remember that plus 2 is positive. So when we were messing with the x's the other day inside the parentheses, and we were adding numbers to it, did it move me left or did it move me right? Because they're saying I can obtain that graph by moving this right 2 units because of that plus 2. So are they actually right or are they false? Oh, good job, y'all. Because remember, we said when we attacked the x inside the parentheses, if A was positive, it actually moved me left. Well, y'all, they said you're going right. So that is definitely false, okay? I'm just gonna click back and see if that'll zip that thing up. All right, y'all. So let's see what we're gonna do. I'm gonna pause my recording because it looks like it's about 10 till. So we're almost done with 7.5 and 6.1's pretty quick. So let's do our break. And then we'll come back and maybe my internet will be kicking in for that math lab, okay? Um, I'm probably just gonna show y'all one. I'm gonna show you one more problem for sure dealing with application using the vertex formula. And then um Are you talking about on the test, Jackson? Um, yeah, I sent that in an email. I can send it again today when I send your stuff out. I sent out a little system of equations for y'all to solve. If y'all sent that back, I'm writing down names on everybody, and then I'm gonna go in and add bonus points to the test. So let me see. Yeah, and people, I just had a few email me so far, but yeah, what I'll do probably either Saturday or Sunday, I'm gonna get on there and update everybody that sent that in, and then I'll go from there. Okay. All right, y'all, I'm just gonna look at one thing real quick, see if Math Lab still spinning there. Okay. All right, y'all. So Math Lab's working again. So take a break. It's what 10:53. I will see y'all at 11:03. Okay. All right, go take 10. Right, guys. All right, y'all showing 11:03, so I'm gonna get us recording and we'll knock out a few more problems in there. All right, y'all, so look what this one's asking for. So let me write this one down. So vertex, so I got f of x equals x squared plus 10x plus 24. So look, they want the vertex, min or max, the range, so that's a new one, intervals of increasing and decreasing, so that's a new one. And then let me see what else. And that looks like it on it, okay? So let's go play with this one. So first of all, what we need is our vertex for sure. So remember here, A is 1, B is 10, C is 24. All right, so let's get that vertex first. So we're going to get our x value. So that's negative b over 2a. So that'll be negative times b, which is 10, over 2 times a, which is 1. So y'all, if you notice, that'll give me what, a negative 10 over 2, which gives me a negative 5. So we know the vertex has a negative 5 for the x value. So we'll come back and use that to get our y value by finding f of that negative 5. So that'll be negative 5 squared plus 10 times negative 5 plus 24. All right, y'all, so negative 5, give me positive 25. Here we got plus 10 times negative 5. That'll make that a negative 50. And then plus our 24. All right, y'all, so 25 minus 50 gives me negative 25 plus 24, which gives us a negative 1. Now, min or max? Well, y'all, do I got a min or max on this graph? So let me pull my chat up. So it's a minimum. Good job, because our A is positive. So let's sort of draw what we got here. We've got our parabola coming down. We know this point right here is a minimum, and it equals negative 5, negative 1. So y'all, this is a minimum. And our minimum value would be the negative 1. So notice, this one didn't ask for the line of symmetry, okay? So the range is the y values. So it's the y values. So for the range, here's my point. So my y values start at this point and they go upward. And if they're going upwards, they're headed towards positive infinity, okay? So we got to start with the minimum y value, which is that negative 1. So y'all, that negative 1 will be in parentheses with a bracket, because the bracket means it includes that negative 1, okay? Remember, when we did interval notation, rounded parentheses, we kick the number out. But if it's a bracket, we keep that number, okay? Now, -1 on the y-axis, my y values head towards positive infinity. Now, y'all, this ain't on this problem, but let me just show you something. If your parabola is upside down, then you would start down here and head up to that point. So you would be starting at -infinity and going to whatever your point for the y value is, okay? So a minimum starts at the y value and heads to positive infinity. A maximum would start at -infinity down here and go until you hit that y value, okay? So I just wanted to show y'all that in case y'all had that kind. Then it asked me intervals of increasing and decreasing. So y'all, here's the thing. Increasing intervals, the graph goes uphill left to right. And the increase in intervals are only concerned with the x values. So these will start with a curvy parentheses. So intervals of increasing and decreasing always have parentheses. So what I look at, uphill left to right. So y'all, that's going to be this side of the graph. It's all going uphill as I move left to right. So what we want to do is see what x value this is, where it started going uphill, and then these x values will head towards infinity. So the x value of that vertex is the x value where it started going uphill. So that would be from -5. And then as my x's go to the right, my graph is going uphill. So the x's are headed towards positive infinity. So this is what we put in the math lab for the increasing. And y'all look here for the decreasing. That's the part of the graph where it goes downhill left to right. And we're still concerned with x values. So for that, this side of the graph right here is going downhill as I go left to right. So I'm looking at my x's here. So the x's are coming in from the left side. But remember, this goes on forever. So these x's are coming in from the left side, way out here. So when that happens, we say they're coming in from -infinity. So I'm coming in from -infinity, going down my x's. My graph is going downhill until I get to this x value right here. Well, y'all, guess what? That's still the x value of my vertex. So these graphs for decreasing on this one are coming in from -infinity until they get to that x value of -5. So remember, the range is worried about your y values, and it will use a bracket because that equals the smallest y value. The reason the intervals are using these parentheses, because this -5, it can't be increasing and decreasing at the same time. So since it's the point where they change over, it don't include that point technically, so it's got the curvy parentheses, okay? All right, y'all, so let's go put this in the math lab and see what it looks like. So we got to do our vertex again. So remember, that's going to be in parentheses. And we got what? -5, comma, -1. Then we said we had a minimum because our A was positive, so we would come to B, and it had the minimum value of that -1. Then it said, what is the range? Well, remember, we said our range was brackets. So let me see on my keyboard, the brackets are right above the enter. So hit the bracket, and it went from -1, comma, to infinity. And infinity always has the regular parentheses, okay? So you check that. Then it says the intervals, it was increasing. Well, we said that was parentheses from -5, comma, to positive infinity, and then close parentheses. So the increasing and decreasing will always have parentheses. And then we said it was decreasing, the part going downhill from a negative infinity, comma, to or -5. So when you're dealing with a parabola, one side will go from the x value to infinity, the other side will go from -infinity to that x value. And it depends on the order based on whether you got a minimum or a maximum on these, okay? All right, y'all, so that's the same thing. So I'm gonna skip through to number 10. So this is the application problem I was telling you about. So they're shooting a toy rocket into the air from a launching pad 6 feet above the ground. And they're telling you the initial velocity is 112 feet per second. So they're giving you a formula for this. And the formula is h of t. So h stands for the height, and t stands for the time since it was launched. That equals -16 t squared plus 112 t plus 6. So all we got to worry about in this problem is that formula they're giving you for the height of the rocket. And our variable is t, which is time, because the height of the rocket depends on how long it was since it's been launched. Okay? So what they want to know is the maximum height. First they want to know how long it takes to reach maximum height. So how long it takes to reach a maximum height, that'll be the x value. And then it says, hey, what is the maximum height? Well, remember, our min or maxes were equal to our y values on those. So y'all, I'm going to go back and share this now. So here's our formula we're using. And then we want to know how long to reach the max height, which we said was the x. And then what was the max height, okay? All righty, so we're using the vertex formula because what this looks like, if you got a launching pad with a rocket and you shoot it off, and let's say that the x-axis is our time, that rocket's going to take off, it's going to go uphill, and then it's going to come back downhill and hit. So this is what we're looking for. How long it took to get here on the x's, and then what was that maximum height, okay? So for us, our A will be -16. So y'all, that's negative. That's why we got a maximum. Like 112. And then C equals a +6. So the time. Time is my x's, we said. That's going to be -b/2a. So that'll equal negative 112 over 2 times negative 16. All right, y'all, so I know that'll give me a negative 112 over negative 32. So let me see, I'm just going to do negative 112 divided by negative 32, and that gives me 3.5. Now, MATLAB's going to let us put in decimals. So let's go put that in real quick. And we know in time has to be positive when you get that. So that's why all my negatives canceled out. And I got my 3.5. So I would check that answer. And then it wants to know the maximum height. So that's going to be equal to the y value. So that means we're finding f of that 3.5. Okay, so what we would do, put 3.5 in for our t. So we got negative 16 times 3.5 squared plus 112 times 3.5 plus 6. So y'all, since I got all these decimals, I'm just plotting this on my calculator real quick. So let me share my calculator. So I'm putting in a negative 16 times 3.5, close parentheses and square that, plus 112 times 3.5, close those parentheses, plus 6. All right, y'all, so when I hit enter, I will get my rocket's maximum height of 202. So that tells me that it took 3.5 seconds for my rocket to go 202 feet into the air. Hey, y'all, so that's basically 7.5 dealing with the vertex. So I can use it for problems like this. Another place where you might see the vertex used a lot is with area problems, because you're dealing with x squared terms in those area problems. So, all righty. Now, 6.1 is really short, but before I do the actual 6.1, I'm going to show you the 6.1 support. And y'all, let me click on that real quick. Let me check something real quick. Okay, yeah, so it's still the same. All right, so 6.1 support is just 3 problems, but it's getting you ready for radicals and doing the domains of a radical. So finding the domain of radical functions. And we're dealing with square roots in here, okay? So y'all, let me ask you this, because I'm looking at a domain. What's the smallest number I can take the square root of and get a real number out of that? What do y'all think is the smallest number I can take the square root of? Oh, what are y'all putting up there? 0, good job. So remember, the smallest number we can take the square root of is 0. Because remember, so recall this. The square root of any negative numbers. This gave me imaginary answers. So these are not real. This produces imaginary numbers. Okay. And all that means is I cannot take square roots of negative numbers because there's not two numbers I can multiply together that's the same number that'll equal a negative. Okay. Like signs are always positive. So when I'm looking at a function, so the domain of a radical function, the first thing I'm going to do is set the radicand greater than or equal to 0. Remember, it can equal 0, and then it can be any number greater than 0 because those are positive numbers. It cannot equal a number less than 0 that is negative. Okay? Now, the radicand, that's the part under the radical. Okay, like this negative a, that would be the radicand. It's the part under the radical. So the radicand is the part under the radical. All right, so once you set this radicand greater than or equal to 0, you solve it for the variable. And then write the domain in set builder notation. And y'all really, support only had 3, so let's knock them out. So for exercise 1, actually all of these, we're going to find the domain of each function. Okay, so number 1, they're giving me f of x equals the square root of 49 minus x. So y'all remember the domain of this has to be values of x that I can put into here and get a real number out of it. So number 1, we said set the radicand. Well, the part under my radical is the 49 minus x. So I'm going to set 49 minus x greater than or equal to 0. Right? That's what we said for number 1. Now we're going to solve for that variable. So first of all, we'll move that 49 to the other side by subtracting. All right, let's see what that gives. Those cancel. I get my negative x greater than or equal to negative 49. All right, y'all. So what I need to know is, what would your next step be here? Tell me what y'all are doing next to that. So now you can either multiply or divide by -1, so that's perfect. But what do you got to do else? Because y'all, that's the inequality there. So if you come in on that inequality and you're dividing by these negative ones, wasn't there one more thing I need to do? There you go. We're going to switch it. Good job. So the greater than or equal now becomes a less than or equal. Y'all cannot forget that when you divide or multiply by that negative one, you got to reverse it. So reverse the inequality. Okay. All right. So that gives me x less than or equal to a positive 49. So y'all, they'll have the little choices here. And all we do, it'll be x such that x is less than or equal to 49 on those, okay? Now, if this was in interval notation, I'm just going to show you to get you good at interval notation. But if this was interval notation, x is less than or equal to 49, that means 49 would be in a bracket on the right side of it. And if you're less than, that means you would be coming in from negative infinity, okay? So your less thans are going to start at negative infinity and go to that number. All right, y'all, so let's try another one. So number 2, they're giving me f of x equals square root x minus 4. All right, so a radical again. And then I'm going to let y'all do number 3 on and just tell me what it's going to be, okay? So for this number 2, I'm going to set x minus 4 greater than equal to 0. So y'all, we just got one move on this one. We're just going to what? Add our 4 to both sides. So I'll bring down my x. Those cancel. Greater than or equal to 0 plus 4 gives us 4. So I'll show you both ways again. Set builder, you would have x such that x is greater than or equal to 4. Interval notation, x is greater than 4. Well, numbers get greater to the right side, so that means 4 would be the smallest number and have a bracket. And from 4, greater than would head towards positive infinity, okay? All right, so on this one, y'all tell me the domain here, okay? Um, so this third one is f of x equals 12 minus x. Oh, y'all sure are taking a while to get that domain. So let me ask y'all this. There's only 2 things we're worried about in this class, member, for domains. The second one is these radicals. Well, y'all, I don't see no radical here. So I'm not worried about radicals on this one. The first thing we were worried about was fractions. Well, y'all, I don't see no fractions on this. So you're no fractions and there's no radicals. This domain is all real numbers. Okay. And in set builder, I mean in Interval notation, all real numbers would be negative infinity to a positive infinity. All right, y'all, so let's knock out 6.1. So here's the thing about 6.1. It's got one problem you got to work, and then the other 5 problems, or the other 6, you're just picking graphs. So I'm going to show you how to draw these graphs on your calculator. And I'll probably do one by hand just to show you the shape of them, okay? So this is 6.1, radical functions. And so the support part was just so y'all could do this first problem here that says, determine the domain of the function. All right, y'all, so they're giving me f of x equals a square root 2x plus 1. Now, they'll give you the answer choices on this one. So we're just going to work it out, and then you would pick A, B, C, D based on your answer, okay? So just like support, I do have a radical. So since I got a radical, we need to set 2x plus 1 greater than or equal to 0. We're going to solve that for our x. Once we solve it for the x, we'll find our domain. All right, so tell me, what is my x going to equal for this one? All right, Jackson, what you got? Negative 1/2. Yeah, that's looking good. Good job. So it looks like you subtracted 1 first, and you got your 2x greater than or equal to negative 1, and then come in and divide by 2. And y'all notice, we did not reverse the inequality because we're dividing by positive numbers. So those 2's cancel, giving me x greater than or equal to negative 1/2. So our choice would be x such that, and y'all, there's only one that looks just like what we got. X is greater than or equal to negative 1/2. So basically your answer will look like what MATLAB has, okay? All right, y'all, so you only had to do one of those. And then they get into graphing. So I'm going to show you a basic graph and then how I would do these on my calculator. So graphing radical equations. And once again, y'all, we're only worried about square root radicals at this point, okay? Not no cubes and all that stuff. So y'all, if I have something like this, f of x equals square root, and I'm just going to use the x for mine, okay? So I'm going to go out, well, let's see. That'll be 5, 6, 7, 8, 9, 10. All right, so that's the y and the x. So, what's the smallest x I can put into this radical? See what y'all think. The very smallest number I can put in. Oh, and y'all done told me this a lot earlier on this section, right? So it's going to be 0. Good job. Which means, because remember, negative numbers make this imaginary, okay? Not real. So I can't use no negative x's. So that means the graph won't be on this side at all unless I throw a negative in the front of that. Well, that ain't even going to do it, right? I can't have no negative x's under that radical or it makes it not real. So the smallest x I can put in is 0. Now I'm just going to put in numbers I can take square roots of. So if you put a 0 in, square root of 0. If you put a 1 in, square root of 1 is 1. So I'm not going to use a 2 because I don't want a never-ending decimal. I'm not going to put a 3 in because that's a never-ending decimal. But I can put a 4 in because I know the square root of 4. Square root of 4 gives me 2. And then if I wanted one more number, I would probably put a 9 in. So when I pick my x's, I'm getting perfect squares that I can take square roots of. Because 5, 6, 7, and 8, those are going to give you decimals. But y'all, the square root of 9 is 3. So the normal basic graph starts at 0, 0, goes to 1, 1, goes to 4, 2. So see, you're doing square roots, so it don't get real tall quick. And then over here at 9 was 3. So they slowly sort of go uphill as you're going to the right, okay? And it just keeps curving up on you. So that's your basic square root graphs, okay? Now I can make them stretch up by putting numbers in front of this radical. See, if I put a 6 here, then every answer I got, I'd have to multiply by 6. So that'd still be 0. But 1 times 6 would make that 6. So it would stretch my graphs up if I got numbers in the front, okay? But your basic square root graph will look like that. So y'all, let me show you what they're going to hit you with. Now they're going to give you 4 pictures to pick these out of, okay? So like number 2 here says graph f of x equals 3 square root of x. Now we know it's still going to go to the right and uphill. All they're doing is making it a little fatter by multiplying by that 3. And y'all, I'm going to go to the graph and show y'all on the calculator. We'll go to y equals, I'm going to clear this. So I had 3 square root of x, so I would hit 3. The square root's over here on the left side above the x2. So it's blue, so you're going to hit the blue second button and then the x squared button. There's your square root, and then put in your x. So now, it's still going to go uphill to the right, but y'all look at the graph. It's just a little bit stretched out, okay? And if you look at the table, all these errors, those errors are because we tried to take square roots of negative numbers. But down here you can see if you pick perfect squares, you get nice numbers over here. If they're not perfect squares, that's what them decimals are, okay? Because the square root of a number is a never-ending decimal if it's not a perfect square. All right, y'all, so let's see what they had next on the problem. So let's see this one, graph f of x equals -2 square root of x. Y'all, what's happening now, remember? The original graphs are coming up like this. Well, what's that negative going to do to my graph? that negative is going to reflect our graph over the x-axis so that it's actually going to be down below the x-axis. Remember, when we did the transformations, a negative in front of our function reflected it over that x-axis. So let's go graph that on our calculator. So y equals, I'm going to clear that out. And we had a -2 square root, so second x squared of our x. All right, so watch the graph. Remember, it's going to reflect it over the x. So it now looks like it's going downhill left to right. Okay, and then if you look at these values, you can see what's happening. Okay, so you're still getting decimals on those values when they're not perfect squares. Oh, y'all, so I'm going to try one more with y'all. So let's see. I'm going to do one like, say, number 6 here. It says graph f of x equals square root 6 plus 3x. Now look, we got more stuff under this Radican. So let's see what is going to happen to this graph when we plot it on our calculator. So I'm going to clear that out. So the square root is second x squared. And then I'm going to put in a 6 plus 3x. All right, so I can still put all this in my calculator. I'm going to hit graph to see what it looks like. So it's still going uphill. But remember, since that stuff is being added, it actually moves my graph left, okay? And that's what sort of happened here, okay? If that would have been minus 3x, watch this. If I make that one positive into a minus and graph it, it moves it right and sort of reflects it, okay? So depending on what you're putting under here, makes a difference on what that graph looks like. So be very careful when you put your stuff in, okay? And then if you wanted to look at your table to see how your values were doing. So since that went left, look what it did. It shifted it over to -2 for the 0 part. And then every number under that made it negative under the radical. So that's why you're getting the error on everything else. So y'all, that's 6.1 just to get you a little practice with those radicals, okay? All right, y'all. So any questions over that? So what we're gonna do Monday, we come in and we're going to be doing some more of that increasing and decreasing, and we'll do what we call piecewise functions. Okay. And that's 6-8. And then 5-4, we learn what we call the difference quotient. So 5-4 is a big section if you're a business major, okay? All righty, y'all. So I'm going to do one thing just to make sure y'all got the idea of some of this stuff. And this is coming back from 7.5, okay? But say I've got a parabola. So we're going to consider this like an after class quiz over today's lesson. So y'all, I've got a parabola sitting over here at the x value of 2 and the y value of 3. So this will be the point 2, 3. Now treat this, whoops, that's a little off. There we go. So ignore that little hump. So I want my graph to go downhill. So here's my parabola. The vertex is 2, 3. What I want to know for this graph right here, what would y'all put for the range of this graph? And remember, the range is those y values, okay? Now remember, ranges always start with the smallest y values and go to the highest y value. So y'all's range, starting at the, oh, Nat, you were so close, but reverse that. And instead of coming from infinity, we're coming in from negative infinity. So remember, when it's a max, you're starting at negative infinity. And then the maximum y value would be that y value of 3. All right, perfect. Now, what is the intervals where my graph is increasing? And y'all remember, increasing and decreasing intervals are looking at the x's. So y'all increasing on this parabola is this part right up here. That's going uphill. So where does it start going uphill at? On these x's. All right, it's way out here somewhere starts to go uphill as I'm cruising down that x-axis, and it stops going uphill when I get to my point right here. So what do we got now? Negative infinity. Good job. Y'all are coming in from negative infinity. And then we're going to 2. Good job. All right, so that means decreasing, which is the right side of this parabola. It is all decreasing over time, but it starts at this point and heads towards. So where's it start and where's it ending? Well, technically, it ain't ending it per se, right? Hey, y'all, good job. 2 to infinity. Y'all, when you got a parabola, one side will be negative infinity to the number, the other side will be the number to positive. Okay? It just depends on whether this is a min or max, okay? All right, y'all, does f of x equals a negative 2x squared plus 5x minus 3 have a min or a max? Oh, y'all got some answers already. What are you saying, max? Good job. That's negative, so that definitely will be a maximum on that, okay? Y'all play with this stuff. That's all we got for today. So play with that. Monday, we'll knock out the last two sections and then we'll start reviewing for your second test, okay? So, remember, test one is due by Sunday night, okay? If you're doing the bonus in the email I sent the other day, that is due Sunday night also, okay? All right, y'all, so let me ask y'all, any questions? All right, y'all, let me make sure I got everybody on my roster real quick. Okay, Raven, I didn't have you, so let me get Raven real quick. Okay, yeah, so today what I'll do, when I send this video out, I'll actually send the actual bonus question with it also. Um, so when you finish the test, um, so when you finish the test, you just gotta send me 5 problems that I asked for, remember? And you gotta upload them in week number 2 under the course content in Blackboard. All right, y'all, so let me make a note of that, okay? I'm gonna email the bonus again. Let me write that down. Yeah, on the bonus, you're just sending me the actual answer you get on this, okay, Jackson? All right, I got everybody. So any more questions, y'all? All right, so look for my video and our bonus to be coming your way probably in about an hour, okay? All right, y'all, that's all I got. So y'all have a good weekend, and I will see y'all Monday. All right, you have a good one, Raven.